Welcome to another plot shot. I'm Mike Gretzinger and we're here at the deep banding trial. This is a trial led by Sept up in the Peace Country, and this is year 3 of 3, so I'm just got one last thing to show you because we'll be done with this project pretty quickly and we won't be able to give you updates on it anymore. So we're out here at the site, and right now we're getting ready to do a couple of things. We're going to be soil sampling right away this week. So if you recall, this project's looking at figuring out what to do about the stratification of immobile nutrients, so specifically potassium, copper, and phosphorus. And so we've got different treatments for each one of our crops, and we've got deep banded and shallow banded combinations of those nutrients. And so what we're doing is we're seeing if by deep banding 3 times rate at the very first year, whether or not we can help get those nutrients further down, and whether or not that's an effective way of putting down immobile nutrients in the first place. So we're going to be soil sampling each of these plots in the fall at a 0 to 3 and a 3 to 6 inch level, and that's going to tell us whether or not we're seeing that stratification. Now we soil sampled in year 1, and we definitely saw that in our soil test, which was really cool to see. You could see the spikes in phosphorus at 0 to 3, and then all of a sudden the rapid depletion of those nutrients in lower layers of soil. And then the other thing we're going to do is we're looking at tissue testing and seed testing so that we can figure out the nutrient uptake of the plants and whether or not plants are uptaking the nutrients differently at the deep banded versus shallow banded levels. So I'm going to show you the biomass samples and kind of how we're assessing that in the lab later on. So what I've got here is 3 leftover biomass samples. We would have taken these before we harvested a couple of weeks ago. And what we did was we went into the plots, we cut a couple meter rows in the front and a couple meter rows in the back. And then so we weighed that, got a wet weight and a dry weight so we can figure out the moisture in the plant here. And then we can figure out a tonnage for biomass. And so this is what's left over from the dryer. So essentially what we're doing to take these into the lab is they'll be pulling out a plant sample. Now when you have a sample, you want to get something really representative. And so in this case, there's 3 calculations we want to know. We want to know the nutrient usage in the whole plant, within the plant tissue, and within the plant grain. And so we really only need to know 2 of the 3 of those to calculate what the third one is. And so for our case, the easiest thing to do is to take a whole plant sample into the lab. They can analyze that, and then to take the grain samples into the lab to analyze that. The trickiest part is to probably get just the plant tissues themselves minus the grains. So that's the one that we're going to do, that we're going to calculate. So if I were to take samples out of here, typically when you're tissue testing, the lab's going to need about 40 grams dry weight, usually a medium to large Ziploc type container full of samples. So all we're doing is filling a Ziploc bag up with a whole plant. This is going to end up in the lab, and then we're going to take our grain sample in as well and calculate our tissue analysis. So we've got that for every single plot that we've done here for all 3 years, and then hopefully that gives us a really good idea of which of these treatments are taking up nutrients at different stages, and how they're using those immobile nutrients, and whether or not they're accessing them at the shallow banded or the deep banded levels. So that's what we're doing. Here's a wheat. Better throw a tag in there. We'll do a little fast forward montage of the canola and the peas. Here's what we end up with. And so this is what we're sending into the lab, and we'll have all this